Today I'm discussing using a thermostat with this PowerPoint controller. I have a meter measuring across this light bulb. I have a switch that shorts out the light bulb. And this switch replicates a mechanical thermostat that you would find on a water heater. So right now we're at 408 watts. And it's 56, 57 volts at the power point. And if you look right here on the meter, across this light bulb we have a half volt, and that's due to these really small wires, which are quite warm. But we don't worry about that. Let me show you what happens. I flip the switch open. Now the current has to flow through this light bulb. It's a 75 watt, and we look and we're still at around 56, and our wattage has dropped down to 14.6 watts. And across the switch we have 12.8283 volts. And if I move over to the lamp, the input of the lamp is 68 volts, 69 volts. So the switch only sees a difference of around 13 volts, which any switch can easily operate under that. In general, any switch under 30 volts can handle DC. So let's see. Now we're back to 403 watts. Now, in my prior video, which showed a relay open and closing, that gave you a good visual of what happens if you have a circuit like this, or if you just do a direct connect and switch around 60 or 70 volts. So let's go up and I'll show you what this looks like. So this is what we have down there. We have the solar panel, and this is your typical lower element switch. I can't control what you're going to do, but you can buy replacements of these, which are upper thermostats, and those contain a separate little switch up here. It's a safety switch. You can put two of those contacts in series, and that can be in series with the actual temperature switch, and that gives you a good safety. So this is what we did. We have the panel. I recommend 2 lamps or a lamp and a resistor. The reason is lamps can fail. They'll go through mechanical shock. The sockets can develop some oxide. So you always want to have some resistance across here. So you can have 2 75 watt bulbs or 2 40 watts. It's really up to you. It doesn't matter that much. And this feeds the capacitor bank. And here we have basically just our shunt regulator. And this is the heater element. And a shunt regulator keeps this capacitor bank at a constant voltage. Now you still have to power it, and that's why we have the resistors. But these limit the amount of current going in. I had tested this earlier when it was only about 150 watts. And the lamp, 75 watt lamp, actually measured like 45 ohms. If you measure the resistance of it, it's 27 ohms cold. And from cold to hot, you get about a 7 times increase. So if you actually had 120 volts across this, it would be 192 ohms. But this value is sufficient to lower the amount of current that are going to the heating element. So it's good to have like 10 watts going in the heating element all the time. That drops the open circuit voltage on this, and if your FETs or capacitor bank are kind of minimal, it's good to have that little extra voltage drop. As you go up in voltage on a solar panel, a little bit of current can drop the panel voltage quite a bit. But this is what I do, and like I say, lamps can fail. If you have two of them, that's redundant, or you can put, my system downstairs has a 270 ohm resistor, and the lamp in parallel with that. And what you'll get is, basically for a 60 volt system, you'll get somewhere around 13 volts across this, so you would be up at 26 volts with a 120 volt panel arrangement. And these contacts, I mean, I can't guarantee it, but the contacts in here are tungsten generally, and in the relay video we had burning up, I use silver because that's what was on the relay, but silver is more visual. It's very easy to get an arc with silver contacts. It's the last thing you want to use on DC, and so if I was going to have any kind of problem, it would have shown up with the relay on those silver contacts. But this works, and like I say, the panel goes up to open circuit voltage. The capacitor bank stays at a constant voltage, and it's the difference between the two that you have to worry about with the switch. So if there's no, once this opens up, immediately the shunt regulator turns off, and then it turns back on again to give little pulses to keep this capacitor bank at the power point voltage. So this voltage always remains the same, and it's because the system is so fast that this works. And the capacitors themselves, even if you didn't have this, would hold the voltage for a very short period of time. Enough for your contacts to mechanically open. So that's what I wanted to explain. So again, you know, 30, 75 watt, even 100 watt lamps. As you can see, with a 75 watt lamp, I was only putting about 12 watts of the heater. And the heating element, most heaters will lose about 50 watts just from heat loss. So putting in a small amount of heat is not a bad thing. It keeps it at closer to temperature for longer. So thanks for watching.